Hello, and welcome to this first in a series of videos on the subject of industrial microscopy. In this video, I discuss a bit about myself, the purpose and plan of the videos, and how I have them organized on my home page. My name is Robert Carlton, and I worked in industrial research and development for about 40 years before retiring. And then after that, I've had a part-time business doing a little bit of consulting and teaching. The aim of this video series is to help show you how to actually use the microscope in solving industrial problems. Some of the previous work that I had done maybe approached the why and some of the theory of it, but in this case, what I'm looking at is really the how. How do you use the microscope? I've been really fortunate to have worked in a number of different industries and with different materials. Worked with fiberglass insulation, with orthopedic implants, with pharmaceuticals of just about every kind and variety. And I've had really a very nice, wonderful career in research and development, particularly using the microscope. I did the bulk of my education part-time and was able to get a bachelor's, master's, and doctorate in chemistry. For my master's dissertation, I used the environmental scanning electron microscope with energy dispersive X-ray spectrometry, looking at qualitative applications. For my dissertation, I extended that to quantitative applications. I also was able to author a book in pharmaceutical microscopy around 2011, attempting to discuss the ways in which the microscope can be used to solve pharmaceutical problems, although I think by and large much of that work would also apply to general industrial microscopy. And so, of course, a lot of the examples I'm going to use in this set of videos come from pharmaceuticals, but obviously not exclusively. In that process, I've had access to quite a few instruments, microscopes of various flavors and sorts. So I have stereo microscopes, polarizing light microscopes, thermal microscopy. I've used image analysis on both optical and SEM images. I've done infrared and Raman microscopy, as well as the electron microscopy, both scanning electron microscopy and TEM. The middle and upper left images here are of my laboratory and instruments at home. So, why a set of videos? Well, I look at this as pretty much a capstone to my career. Now that it's sort of drawing to a close, I think the one thing I might be able to add is some how-to advice about where do you start when you want to determine what the black spots are on a tablet, or you have some powder that's been given to you. And you need to know something about the particle size and particle shape. How do you estimate something like the polymorph transition temperature, all using the microscope? So to sum it up, these videos are intended for the working analyst who needs to do a job and do it quickly and efficiently and still provide relatively high quality results. That being said, the two operating principles that all of my work as well as what I've taught, all of that, the guiding principles are really two. The first is the quality of the work is directly dependent on your skill as a microscopist. And the second is the quality is directly related to how well you can sample and the quality of the sample that you're able to produce. And so, in order to really gain this kind of experience, I'm hoping that these videos will give you a bit of a shortcut to say, well, here's some of the tricks of the trade that will help you to be able to solve some of those problems and gain experience. Skip Palahniuk, who is the founder of Microtrace and is, and I don't think it's hyperbole that he's one of the a world-renowned forensic microscopist. He also taught at Macron Research Institute, and I took a couple of courses from him. Back in 1979, he made this point, and I think he said it quite well, which is the limitation is often not the instrumentation, rather it's the experience and the skill of the operator. And although knowledge and understanding and whatnot we can help get with books and with videos and listening to talks and reading journal articles, in the end you have to spend a certain amount of time actually practicing these things in order to get good at it. The subjects I'm going to cover are solid state form analysis, in other words, looking at polymorphs, solvates, hydrates, particle size and shape, contaminant identification, which I think contaminant identification is one of the most important things that an analyst can do within the company. And then I have a number of videos on actually how to set up and use the instruments. I've organized the videos into different playlists according to subject, and I really love to be able to get 4 or 5 videos done in a month, and I want to try to keep them between 5 and 10 minutes, although I have a tendency to run on, so that may not be quite so easy to do. Please feel free to comment and ask questions. As I said, these are really designed to be, these videos are designed to be a supplement to my book on pharmaceutical microscopy. And I'll also be using my website to attach additional information, and feel free to comment there as well. Well, I love using the microscope. From the first time that I saw a polarized light microscope image of a thin section way back when I was doing glass analysis, I just fell in love with using the microscope for things. One reason is, as you can kind of see here, this is a pretty picture, but it's also can be very instructive. You can learn a lot about that material using the hot stage and doing testing with it. And so I very much have enjoyed that intersection between aesthetics and beauty with practical applications. I hope I can transmit a bit of that to you, and I hope you enjoy learning about how to use the microscope for industrial applications.